Okay, so today's topic is solve rational equations. Rational equations are equations that have rational expressions, like what you see over here, 1 over x. So this equation is a rational equation. You could just think of them as equations that have fractions and the variable is in the denominator. Starting with example 1, the first thing that you do when you solve a rational equation is to check all the denominators. Let's highlight them. We have x, we have 3, we have 5. So I'm going to just highlight the ones that have x, which is right here. Since this one is x, it's a variable. We don't know the value of this, but one thing we do know is that x cannot be 0. This is because if x is 0, 1 over x will be undefined. And why does that matter? This matters because sometimes when we solve a rational equation, we might get solutions that are restricted, like this one. We might get x equals 0, but because we know x cannot be 0, you eliminate that solution. So how do you solve a rational equation? There are multiple ways that you can solve. I'm going to show you both of them using example 1, and you're going to make a choice. The remainder of this video, I will use one of the methods. So method number 1 is you could convert all of them to the same denominator because we have fractions, right? So that means we need to find LCD. The denominators here are very simple. It's just x, 3, and 5. So we know the LCD is simply the product of them, and that will be 3 times 5 times x. And this will give us 15x. That's the LCD. And once you have your LCD, you convert all of these fractions to the same denominator. Let's write down the first one. So for this one, if we need to convert it to the LCD on the bottom, we need to multiply both the top and the bottom by 15. This is the transformation. Next, 2 over 3. And if you compare this to our LCD, it's missing 5 and x, right? So we need to multiply both the top and the bottom by 5x. Equals 1 over 5. We also need to do the transformation. This one, if you compare it to the LCD, it's missing 3 and x. So we need to multiply both the top and the bottom by 3x. Once we do the transformation, we will get 15 over 15x plus 10x over 15x equals 3x over 15x. And notice that they have the same denominator, right? 15x, 15x, 15x. So you could combine the left-hand side, or you could just say that since these are just fractions with the same denominator, we can simply get rid of the denominator and write down that the numerator must be true. For the equation to be true, the numerator, 15 plus 10x, will be the same as 3x. And then this equation, as you can see, doesn't have fractions anymore. We can solve it as usual. We have x on both sides, so I'm going to subtract 10x to move my x to the right-hand side. You could also move 3x to the left. The left side will become 15, and the right-hand side will become negative 7x. And then we will divide both sides of this equation by negative 7, because that's the operation on the right-hand side, multiplied by negative 7. Once you get rid of the negative 7 on the right-hand side, we have x. And then on the left-hand side, you simply write it as a fraction, negative 15 over 7. This number is not 0, so we can safely say this is the solution. And that's method number 1. If this method works for you, you could just use this method. And I would say most people are probably familiar with this method because you need to do the transformation anyways for a lot of rational expressions. And then method number 2, it's very similar to method number 1. The first step for method number 2 is the same. You find LCD. So we already did the LCD earlier. I'm just going to say it's 15x. Once you have your LCD determined, you're going to multiply everything in your equation by this LCD. The resulting equation will be very similar to what we had earlier. So I'm going to multiply 1 over x by 15x, and then plus 2 over 3 by 15x, and then equals 1 over 5 by 15x. And then I'm going to cancel out some common factors. So you have x and x, they cancel out. 3 goes into 15 5 times, or you could do 15 divided by 3, that's 5. And then on the right-hand side, 15 divided by 5, that's 3. So you crossed out all the denominators. That's the purpose of multiplying everything by LCD. Let's write down what's left, right? We have 1 times 15, so that's 15, plus 2 times 5x, that's 10x, equals 1 times 3x, that's 3x. And as you can see, this is the same equation, right? This equation is the same as this equation right here. So you could do the same thing after this. Isolate x, and then you will get x is negative 15 over 7. So this is method number 2. You will pick one of these 2 methods and practice for this handout. Since I think most people are familiar with method number 1, I'm going to use method number 1 for the demonstration of all the problems, all the examples on this handout. Please pause this video and use practice 1 to test your understanding. You could pick any one of these 2 methods or come up with a new method that might be even better. And this one, I'm going to give you the solutions right here. This one, the solution is 15 over 13. So go ahead and test it out, see if you get this number. Okay, let's move on to example 2. Example 2 is another rational equation because we have fractions and the variables are in the denominator. Starting with the first step. So the first step is not LCD. Keep in mind, the first step is always finding out the restrictions. Remember, a fraction, the denominator cannot be 0. So let's identify our denominators. We have x, we have x squared. Those are the 2 denominators, and we're going to make them non-zero. So x cannot be 0 again. If you do x squared cannot be 0, this indicates that x cannot be 0, right? Because if x is 0, when you square, it will also be 0. But in general, our restriction is this. X cannot be 0. Keep that in mind. Okay, and then I'm going to do LCD. And I'm going to use method number 1 to demonstrate. So for LCD, I'm going to look at the denominator and factor them. The first denominator is just x, and the second denominator, x squared, is x times x. And then I'm going to use the column method, as you remember, to conclude that our LCD is x times x, which is just x squared, right? Which is just x squared. And then I'm going to convert everything in my equation to the common denominator. So for the first one, it's just 1 or 1 over 1. We need to multiply both the top and the bottom by x squared, because that is the LCD. And then the second one is negative 2 over x. It is missing x on the bottom, so I'm going to multiply both the top and the bottom by x. Let me change how I write over here. So this is multiply both the top and bottom by x squared. Okay. And then on the right-hand side of this equation, We don't need to do any transformation because the denominator is already LCD x squared. Let's write down the resulting equation. So we have x squared over x squared minus 2x over x squared equals 15 over x squared. They have the same denominator, so we could simply cross them out and write down the resulting equation. Let's write it over here. So this will be x squared subtract 2x equals 15. And this is a quadratic equation. For quadratic equation, so far, the method that we discussed is solving by factoring. And that requires you to move everything to one side of the equation and then factor to create a zero product. The easiest way to do is subtract 15 from both sides. And this will create a 0 on the right-hand side of the equation. On the left-hand side, we have x squared minus 2x minus 15. And now we're going to create a 0 product by factoring. On the left-hand side, we have 2 pair parentheses. Don't forget that equals 0. Let's factor the left-hand side. To get x squared, we need x and x. To get negative 15, we have multiple ways. The middle term is negative 2x, so I'm going to try negative 5 and positive 3. Let's test it out. The outer two terms, I get positive 3x. The inner two terms, I get negative 5x. And if I add these two, I get negative 2x. And that is definitely what we need in the middle. So this is the right way to factor it. Okay, and once you factor the left-hand side, we will apply the zero product property, saying that each factor we see right here could be 0. So we have two equations. X minus 5 is 0, x plus 3 is 0. We solve each of them for x. This one will be plus 5 on both sides. And we obtain x is 5. The second equation, we subtract 3 from both sides. And we obtain x is negative 3. Before we box these two answers, we're going to check the restrictions. So what is our restriction? X cannot be 0. And none of these is 0. We can safely box both of them. So x could be 5, x could be negative 3. Okay, let's use practice 2 as a practice. I'm going to give you the solution so you will check, see if you get it right. For this one, y could be 6 or y could be negative 2. So we have two potential solutions. Example 3. Example 3, I'm going to do the method number 1 again. Starting with the restrictions, right? We have 3 denominators. And then for each of them, you're going to see what value is restricted. Let's make the first denominator as 0. If I make x plus 1 0, I will get x is negative 1. So we know that x cannot be negative 1. That's the first restriction. Second one is x minus 1. And we know that that cannot be 0. If I plus 1 on both sides, I obtain that x cannot be 1. And then the last one is x squared minus 1 cannot be 0. If I move the negative 1 to the other side, I will get x squared cannot be 1. And this, in the future, we will talk about how we solve this. But now you could just use trial and error. You should see that x cannot be 1 or negative 1. Because if you square 1, you get 1. If you square negative 1, you also get 1. So what's our overall restriction? Overall restriction, x cannot be 1 or negative 1. So that is the overall restriction. When we solve our problem, we just have to keep that in mind. Okay, next we need to find out LCD. So let's factor all these denominators. X plus 1 is just x plus 1. X minus 1 is just x minus 1. and I need to vertically match these factors. So I'm going to put it right here. X squared minus 1, we're going to use the formula for a squared minus b squared. It's x plus 1 times x minus 1. And now we can see that there are two factors in this case, which indicates that our LCD is the product of these two, x plus 1 times x minus 1. And then I'm going to transform the equation so that they have the same denominator. The first one is 2 over x plus 1. And I'm going to multiply both the top and the bottom by x minus 1. Because that's what is missing from LCD. Plus 1 over x minus 1. This expression is missing x plus 1, so I multiply both the top and the bottom by x plus 1 equals 1 over, this denominator x squared minus 1 is our LCD, so we don't need to do any transformation. But I'm going to rewrite this using the factor form. Okay, now our equation is transformed to fractions that have the same denominator. We can cross out all of the denominators. And then let's write down what's left. We have 2 times x minus 1 plus 1 times x plus 1 equals 1. And now we're going to distribute to get rid of the parentheses. Distribute. And this will give us 2x minus 2 plus x plus 1 equals 1. Combine like terms on the left-hand side. We have 3x and then negative 1 equals 1. Do inverse operation, plus 1 plus 1. We have 3x is 2. And divide both sides by 3. We obtain that x is 2/3. And this value is not 1 or negative 1, so we can say it is the solution. Okay, let's use practice 3 as a practice. For this one, I can give you the solution. Y is 2. Okay, example 4. Example 4 is just as complicated as example 3. So we're going to use the same method to solve. First, identify the restrictions. I think it will be better if we factor the denominator, which will help you see what the restrictions are. So let's actually factor all the denominators. The first denominator is x squared minus 7x plus 10. If I factor it, you might guess it, it's just the other two denominators that you see, x minus 5 and x minus 2. And you could verify that it will give you negative 7x in the middle. Second denominator is x minus 5. It will turn into x minus 5. And then the last denominator, x minus 2, will turn into x minus 2. So there is a different way to find restrictions. You just need to see your LCD is not 0. In this case, our LCD, if you do the columns, we have 2 factors right here. And that tells us that our LCD is simply the product of these two. It's x minus 5 and x minus 2. And your LCD cannot be 0. So this is like another way to find restrictions. LCD is the denominator. Denominator cannot be 0. And then from this, we should get 2 restrictions. X cannot be 5, right? If x is 5, this left-hand side will be 0. X also cannot be positive 2. If x is 2, this will be 0, and this will turn into a 0 product. So this is another way to find restrictions by looking for the LCD and see what values will make LCD 0. This is extremely useful when you have complicated denominators like this, or you have 3 denominators. You don't have to check each of them anymore. You could just use the LCD to find the restrictions. Okay, we have this LCD figured out. Let's do the transformation. On the left-hand side, we don't need to transform because the denominator is the LCD. I'm going to rewrite this using the factor form. All right, on the right-hand side, the first one is 6 over x minus 5. It's missing x minus 2, so I'm going to multiply both the top and the bottom by x minus 2. Next one is negative 4 over x minus 2. This one, it's missing x minus 5, so I'm going to multiply both the top and the bottom by x minus 5. And now we have common denominators. We can cross out all the denominators. Let's write down what's left. So we have x plus 13 on the left, and then 6 times x minus 2, subtract 4 times x minus 5. Just keep in mind that if you use this method, you will not have denominators. Same thing with method 2 actually. Method 2 will also get rid of the denominators. Now let's distribute. So on the right hand side, we have parentheses that we need to get rid of. Let's simplify. On the left hand side, it's just x plus 13. On the right hand side, after we distribute, we obtain 6x minus 12, and then minus 4x, and then positive 20. This is, be careful right here. We're distributing negative 4 and multiply by negative 5. So as a result, we get positive 20. Okay, on the left-hand side, we can't do anything. On the right-hand side, we have common terms, right? We have like terms that we can combine. So 6x minus 4x, that's 2x. Negative 12 plus 20, that's positive 8. And this is a very simple equation. We just simply need to isolate x. I'm going to move x to the right-hand side. And this will give me 13 equals x plus 8. And then we will subtract 8 from both sides. And this will give us 5 equals x. And what do you see? Do we box this? We do not, right? Why is that? It's because of the restrictions right here, remember? X cannot be 5, x cannot be 2. If x is 5 or 2, the denominator will be 0. So what do you write then? We eliminated x equals 5. You will just say no solution in this case. And that will be what you write if you eliminate all possible solutions. Let's use practice 4 as a practice. The solution is no solution. Okay, example 5. Let's start with the LCD. X plus 4, we factor into x plus 4. X squared minus 16, it's in the form of a squared minus b squared. This is because 16 is 4 squared. So we can apply the factoring formula. It's just x plus 4 times x minus 4. And then we're going to apply the vertical factors. So we know that LCD is simply the product, x plus 4 times x minus 4. Let's do the transformation. X over x plus 4. It's missing x minus 4. I multiply both the top and the bottom by x minus 4. Equals 32 over, this is our LCD, so we don't need to do anything other than just change it to the factor form. And then plus 5 over 1. This one, it's missing both of the factors, so we need to multiply both the top and the bottom by the LCD itself. And then we have a common denominator. We can cross out all the denominators. And let's write down what's left. So we have x times x minus 4 equals 32 plus 5 times x plus 4 times x minus 4. Let's simplify this by distributing. So we have right here, distribute. And then over here, this piece is simply x squared minus 16, right? Because we factored it. We could use the original expression instead, or you could FOIL. X squared minus 4x, that's on the left-hand side. On the right-hand side, we have 32 plus, so right here, I am distributing 5 into x squared times 16, right here. And this will give me 5x squared minus 80. And we can combine the two numbers on the right-hand side. So it's 5x squared, and then we have 32 minus 80, which is negative 48. And I have x on both sides of the equation, and this is the quadratic equation. So same thing, we're going to move everything to one side of the equation. Since the coefficient of x squared is 5, which is greater on the right-hand side, I'm going to move everything to the right-hand side. Inverse operation, subtract x squared plus 4x, because there is a hidden plus right here. And you're going to do the same thing on the right-hand side. And this will give me 0 on the left. On the right-hand side, it's 4x squared plus 4x minus 48. And we're going to factor the right-hand side. First thing I'm going to take out is a GCF. So there is a GCF of 4. And this will make the inside x squared plus x minus 12. And then after this, we're going to factor the quadratic part to make a zero product. So we have 0 equals 4, and then we have 2 pair of parentheses. We are factoring this part right now, x squared plus x minus 12. To get x squared, we know it's x and x. To get negative 12, I'm going to try positive 4 and negative 3. It's negative, so the two numbers that you pick should be one positive, one negative. And then if you do the outer and inner, let's see what we have. The outer is negative 3x, and the inner is 4x. And if I add these two, I get x. And that is indeed what we need in the middle. So this is the right way to factor it. All right, now we have a zero product. We can use the zero product property. Each of the factors could be 0. How many factors do we have? We have 1, 2, 3. The first factor is 4. That cannot be 0. So it must be these two factors. And we're going to create two equations. X plus 4 is 0. X minus 3 is 0. Do inverse operation to solve x. The first equation yields x equals negative 4. The second equation, you plus 3 on both sides. And it yields x equals 3. And before you box these answers, double check the restrictions, right? And I guess I forgot to do the restrictions earlier. Some of you might be screaming in front of your screen. So what's the restriction? We check our LCD right here. Apparently this cannot be 0, which means x cannot be -4, because if x is -4, this will be 0. And then there's one more number x cannot be, which is 4. This is because if x is 4, this part will be 0. So we have two values that x cannot be, -4 and +4. And we do happen to have one of them right here. -4 cannot be the solution, so you could just cross it out. And we have one solution, which is 3. So you should box this one. And this is the tricky part about the rational equations. Especially when you have multiple solutions, make sure you double check, see if you will accept both of them. And the way to check it is just use your LCD. Your LCD cannot be 0 because that's the denominator. Your LCD will tell you the restrictions of the value of x. Okay, and as you can see, I did a lot of work for this problem. You probably did the same. So I guess you don't have any space for practice 5. I recommend that you just write it somewhere else in your notebook or something. But I'm going to give you the solution to this. This one is y is 7. So for this one, you will get two potential solutions, just like example 5. But one of them will be eliminated. So be careful when you solve practice 5. Okay. The next section is solving rational equations for a specific variable. This one is basically using formulas, and we have multiple variables in the equation. Because we have multiple variables, we cannot get a specific value as the solution. Instead, we will get an algebraic expression as the solution. So let me show you what I meant by that. Example 6, we have this equation, m equals y minus 5 over x minus 4. We're solving for y, so I'm going to circle y. And we're going to do inverse operations, right? In order to isolate y, the first thing that I can do is I can multiply both sides by the denominator x minus 4. So that's what I'm going to do. Let me copy the equation first. I'm going to multiply both sides by the denominator x minus 4. The reason why I do that is because by doing that, I can cross out the denominator with the x minus 4 on the right-hand side. And that will give you a much easier equation to look at. So on the left-hand side, we can distribute m. And that will give us mx minus 4m equals, on the right hand side, it's y minus 5. And again, we're isolating y, right? So I circled that. The inverse operation, plus 5. So we plus 5 on both sides. And now we have an algebraic expression on the left hand side, mx minus 4m plus 5 equals, on the right hand side, it's y. And that is our solution in this case. We successfully isolated y, which is equivalent to solving this equation for y. And the ones that I highlighted right here, this is an algebraic expression. It's not a numerical number. We don't know the value of m, we don't know the value of x, but it's fine. We have an expression for y. That's the solution. Okay, let's use practice 6 as a practice. Okay, hopefully you did this one. So I'm going to give you the solutions. Y is mx plus 5n plus 1. So it's very similar to example 6. All right, example 7. We have 2 more problems left. This one is solve this equation for A. Solve this equation for A. Let's circle that. It's right here. So one thing I'm going to do is I might subtract 1 over B from both sides. Because I want to isolate A, but I do have a 1 over A. I think one thing I can do is I can keep 1 over A on one side of the equation, right? So on the left-hand side, we get 1 over A. On the right-hand side, we have C minus 1 over B. Not bad. Next, we still need to isolate A. So how do we do that? Notice that on the left-hand side, it's just 1 over A, which is the reciprocal. So why don't we just take another reciprocal of 1 over A? If I take a reciprocal of 1 over A, I will get an A. But you will also need to do the same thing on the right-hand side. So I will take a reciprocal of the right-hand side, which is the same as putting 1 over the original right-hand side. This will be taking a reciprocal on both sides of the equation. And doesn't this look familiar right here? If you remember today's quiz, hopefully you did the quiz. The quiz problem has something to do with this, right? So this is a complex rational expression, which we did in the previous handout. And there are different methods that you could do to simplify this. So let's actually simplify this. The method I'm going to use is LCD. I'm going to multiply everything by LCD, but you can combine the denominator to make it a single rational expression, and then you do the division of fractions. Since there's only one denominator, let's highlight that. It's just B. Your LCD is B. And then I multiply everything by B, because that's the second method that we discussed. So on the top, multiply by B, C multiply by B, 1 over B multiply by B. And this will give me a simplified rational expression. So on the top, 1 times B is B. And then on the bottom, C times B is BC, or you could also say CB. And then subtract 1 over B times B. 1 over B times B, in this case, the B and the B, they cancel out because it's a common factor. So we simply have 1 left. And that's the answer. Oops. Okay, so for practice 7, this one I will guide you through because this one might be a little bit harder for you to solve on your own. This one we're solving for y, so let's circle that. Let's circle that. And notice that this 1 over y is already isolated. It's on the right-hand side. So we could use the same strategy, right? What's the strategy? Reciprocal. So I'm going to take a reciprocal on both sides. On the right-hand side, it's going to become y, right? And then on the left-hand side, it's going to be 1 over the left-hand side. So 2 over x plus 1 over 3. And by the way, you could also combine the two rational expressions on the left-hand side and then take a reciprocal, which might be easier. I think speaking of that, maybe that's easier. Let's actually do that. So the first thing you do is combine the left-hand side. The LCD of the left-hand side, we have 2 different denominators. So that means it's going to be 3x. So I'm going to multiply the first one, both top and bottom, by 3. The second one, both the top and bottom, by x. And this will give me, let's get rid of this. This will give me the 6 over 3x plus x over 3x, right? And if I add them, I will get 6 plus x, sorry. I will get 6 plus x over 3x. So this is the left-hand side. Let's rewrite the equation now. We have 6 plus x over 3x equals 1 over y. And then we are asked to isolate y. It's a reciprocal on the right-hand side, so we will take a reciprocal on both sides. Let's do the right-hand side first. The reciprocal of 1 over y is y. On the left-hand side, the reciprocal of this rational expression, you simply flip it upside down. We get 3x over 6 plus x. And that's it. That will be the final solution right here. All right, so this is the handout L9. If you do have questions, please feel free to contact me. And that's it. Thanks for watching.